It says here, guys, a survey conducted among 48 persons to find out what mobile network they use. So the table below shows the results of the survey, right? Cool. So the results of the survey says 20 people use Wiretech, 12 use Digilec, 10 use Ophone, and 6 use other, right? And it says here, if this information is to be represented on a pie chart, what is the angle for the sector that will be represented by Ophone? So this is really easy, guys. So if we add all of these together, cool. If we add all of these together, guys, the total, let me write total up here. The total for these is going to be 38. 10 plus 20 is 30. Well, no, not 38. 48. Cool. Yeah, 48. So the total is 48, guys, for all of the different types of persons using different types of phones. And it says, what's the sector for the Ophone? So Ophone is 10 out of 48. I would just multiply that by 360 and we would get our answer. Cool. Yeah, we'd get the answer then. And I think 360, can 48 go into 360, guys? I think it can. 360 divided by 48. Not completely. Not completely. But if we multiply this, guys, well, 12 can go into 48, am I right? 12 can go into 48?
4 times, yeah.
Yeah, 4 times. And 12 can go into 360.
30.
Yeah, 30 times. So I would end up with 30 times 10, which is 300 over 4. And 300 over 4 is the same thing as 75.
So 75 degrees.
So it would be 75 degrees for the Ophone. So Ophone, well, O-F-O-N-E, Ophone would be 75 degrees. Cool. Yeah, Ophone would be 75 degrees. And then it says here as well, using the circle below with the radius shown, represent the information in the table clearly on a pie chart. So guys, we kind of have to think about this one now. So Ophone would be 75 degrees and that makes perfect sense, right? So we can definitely draw 75 degrees. This would be 90 degrees. So 75 degrees would be about like that, right? So this would be the Ophone section. This would be for the Ophone at 75 degrees. But we'll have to think about the others, guys. We'll have to think about what the others would be as well. Cool. Yeah, I think this would be about 75. But we'll have to think about the others as well, guys. One is 12 over 48, one is 6 over 48, and one is 20. So it would be 12 over 48, which is times 360. That would be the next one. Then 20 over 48 times 360. And then the last one is how much? 6 over 48 times 360. So 12 goes into 48 4 times. So this is going to end up being 4 into 36 goes 90 degrees. So there will be another 90 degrees somewhere. So let's put a 90 degree one here. And I think that would represent, let's scroll up to see 12, that would be Digilec. So 90 degrees would be Digilec. Digilec would be 90 degrees, a 90 degree angle. Let me just draw a 90 degree better than that. So this one would be 90 degrees for the Digilec. And the other two are Wiretech and other, right? So the 20 would be Wiretech. And this one, the last one would be other. So this one would be Wiretech. And this one would be other. So 6 goes into 48 how many times? 8. And 1/8 of 360 would be 45 degrees. So there's one that's 45 degrees. And I think that would be like this. So there's a 45-degree angle for other. So other would be 45 degrees. And we don't even need to find the other one. The last one now is going to be 360 minus 90. That's 270 minus 75. That's 195. And then minus 45 would be 150. Yeah. So the last section, which is 150 degrees, is for the wire tech. Cool. And that would be the pie chart, guys. This would be perfect, actually. Yep, this would be perfect how I drew it. It looks good. It looks good. It looks good to me. Romario, manageable?
Yes,
Jaden, makes sense? Nikolai?
I
think it
just
makes
got
sense,
here.
guys.
But it looks like it makes sense.
Tajan, it makes sense? Focus, Jaden. Focus, man.
No, I had to do something on the break and I came back.
Okay, cool, cool. So guys, that covers the pie chart. I think that's really simple. Cool. Okay, so let's go down now. And it says, well done, Tajan. And it says, the incomplete table below shows the results obtained by 200 boys and 250 girls on a Spanish examination, right? So this is the situation, guys. 200 boys, 250 girls. Standard deviation is 8.2. I don't know the rest still. So it says here, calculate the probability that a girl receives a grade 1. So it's kind of obvious, 62 over 250 would be the probability. And if we work that out, guys, we can use a calculator still. It's 250 girls, so. But wow, when I really think about it, it's like they made it that only the girls did well. This is a weird table, but yo, I don't like this table at all still. It's like trying to say the girls doing better than the boys, you know? Kind of thing this CXC, this really set away, man. I don't like this, but okay, so the probability that a girl would get a grade 1 is 0.248, which is basically the same thing as 24.8%. So that's the probability. And it makes sense, guys, because only 62 girls out of 250 got a grade 1. So that's the probability, right? So that was really easy. And the next one now, it says, what percentage of the boys who took the exam achieved grades 1 to 3? 1 to 3? There's a 1 there, man. There's a 1. Oh, you know how many boys got a 1?
add 38, 34, and 5. So you subtract that from 200. And
Oh yeah, that makes perfect sense. Okay, okay. So guys, yeah, they're asking for the grades from 1 to 3, which is here to here. So it's 200 boys. So you can subtract the 30 and the 8, and that would give us 162 boys between grade 1, 2, and 3. So that makes sense. This is kind of simple, not too bad. It's just like a pattern, guys. You just need to say, oh, common sense, right? This is a common sense question still. So yeah, common sense from the table says 162 boys got 1, 2, or 3s. And it says what percentage of boys who took the exam got 1, 2s, and 3s. So if 162 boys got 1, 2s, and 3s, out of the total, which is 200 boys, then that would be 162 over 200 times 100%. This 100 cancels into this 2 times, and if we divide 162 by 2, we're going to get 81. So it's 81 boys. So this was a weird question, but it was kind of simple when you really think it out. You just have to look at the table, guys, and use common sense. Common sense prevails in this one. Yeah, you just have to look at the table.
81%, right?
Sorry, 81%, not 81 boys, 81%. 81% of the boys, sorry. 81% of the boys. Sorry about that, guys. Cool. 81%. Cool. So I think this is cool.
Sure.
I think this is okay. Go ahead, Adrian.
So go back over before you get the 162.
162. All right. So let me go over it one more time. So guys, it says here, find the percentage of boys who achieved the grades 1 to 3. But if we look at the table, guys, it's really the table that really helps us, you know. It says we don't know the amount of people who got 1s, 2s, or 3s. We don't know, but we know how much didn't got 4s or 5s. So the amount of boys that got 1s, 2s, and 3s would have to be 200 minus the 30 and the 8. So we know 162 boys got 1, 2, and 3. So for this section here, we know that the 3 of them added together would be 162 boys, because the rest is left. It's 200 boys, you know, so there's no other way to find it, right? So that gives us enough to find out the percentage. If 162 boys over 200 boys, if we multiply the percentage, we'd get 81% as the answer. Make sense, guys?
Yeah.
I think it makes perfect sense. So let's do the last thing now. On this, it says here, considering the standard deviations in the table on page 18, compare the performance of boys to girls. Wow, standard deviation, really? Standard deviation 8.2, 6.3. Man, this is a hard question still. I'm not gonna lie, guys. Why would they ask you that? .2, 6.3. This is a weird one. It's a weird one. I'm not really getting the logic out of this. Trey, think you can manage this one? You guys were supposed to try this paper still.
Yeah, I know. I have an answer. I put something about the girls' standard deviation was closer to the expected average versus the boys' own due to the low standard deviation. And so the boys' standard deviation was further away from their expected average. Something like that.
That makes a lot of sense. That's very, very sound, actually. That's really very smart. But guys, this is one of those questions where, to be honest, it's not so easy, you know. Well, first of all, guys, standard deviation is usually around the expected average. So anytime your standard deviation is higher, so for the boys, it's 8.2 and the girls is 6.3. Sorry. Yes. So for the boys, the standard deviation, the SD, let's call it standard deviation, is equal to 8.3, and the girls, it's 6.2, right? So the answer for this, guys, is 6.3. I have it the wrong way around. Yeah, 6.3 and then 8.2. Cool. So this is the standard deviation, guys, right? Now, right. What makes this say who did better? So the fact that the standard deviation, the SD for the boys is bigger. This means, guys, that on the graph, most of the people didn't get what they expected to get. So because the standard deviation is bigger, guys, most boys didn't do as well. It's just that simple. Most boys did not do as well as expected. Right? And then same thing with the girls. Well, the girls only is lower, so the girls did better than the girls didn't do better than expected, but the girls did better than the boys because the standard deviation is lower. Meaning that the girls did better than the boys because they were closer to what was expected for them. Cool. They were definitely closer to what was expected for them. Cool. So that would be the answer for the 1 mark. That's all you really have to state. And that's good. But this is another thing to guys that, yo, if you don't know,